for interruption. So I welcome Alex De Sebastian for a very important issue, and this is seventh lecture in a series that is on climate change, vulnerability, and risk mapping. I'm sure that in the last 2 days you must be highly benefited with the deliberation of the Alex. So I welcome Dr. Alex, and over to you, sir.
Okay, so one thing that I learned yesterday was, well, actually this morning as I was having breakfast with some of the participants, is that some of you were actually looking forward to the index construction effort as a tutorial. And I chose to substitute yesterday the exercise that we all participated in, right? The causal mapping, which I hope you found useful and profitable, but I do have one more lecture that was supposed to be on urban-related risk and vulnerability on Friday. And what I'll do instead is use that as an opportunity. So I'll provide some data in advance tomorrow or even this evening possibly, a very simple exercise in a simple index construction so that you can we can practice in class developing the index, okay? So I apologize that that's a little out of order in the sense that it's not in the order that we originally proposed, but I believe that it will still be fruitful. And I can't teach, everything that I normally teach about composite index construction in a 10-week course. Well, actually, it's a 14-week course at Columbia University, but I can give you some of the essential elements and point you to some useful reading on the subject so that if you need to develop your own indices in the future, you can rely on that material for future development. And today, actually, we'll be talking a bit about index development in the context of climate vulnerability and risk mapping. So you can, this is a teaser and a taste of what, you may be able to do after you complete this course. So I mentioned that I wrote my dissertation on mapping this concept of vulnerability. And we already know this because we talked about it, right? And then I mentioned about in the 1990s, there was this kind of awakening led by Susan Cutter, a professor at University of South Carolina, who has, by the way, had many students go on to do amazing things in this space. She developed this thing called the SOVI using census data. And I mentioned that the SOVI is now being used by FEMA, the Federal Emergency Management Agency, to guide their work. So we've talked about how indicators can in turn be combined with hazard, risk, climate, and exposure data. So you can take these social vulnerability indicators, combine them with data on hazard and risk and exposure, and begin to develop new insights into climate vulnerability. Furthermore, what we're going to talk about today is you don't have to be limited to solely working on the, admin 1, admin 2, or admin 0 data, admin 0 being state level, admin 1 being provincial or state level, admin 3 being generally, what's the name of it in district? What's below that again? I always forget. TESOL, thank you. I heard TESOL, thank you. In the U.S., it's census. We go from state to county, and then we go down below that. It's typically towns and villages. That kind of thing. Yeah, that's a district is a county, and in Spanish it's municipio. They call it. So the names vary. One reason why they came up with that convention of admin 0 down to admin 4 or even admin 5 is that, because the names vary around the world, you want to have some consistent nomenclature. So I did my thesis on the topic of climate hotspots. We're going to talk more about this systematic review today, and I better get my timer out because I'm going to, you know how I am, I tend to go on sometimes. I need to keep time. So let's get the timer out. All right, 1 hour and say 10 minutes. And let me add a couple zeros. So that's it. There we go. All right. And so, this idea of hotspots kind of led, or, ultimately to my notion, my thinking was, well, if there's really extreme hotspots of climate vulnerability, then there's likely to be some kind of migration out of those areas. That was my thinking at the time. Now, and we'll talk about it more tomorrow, we know that there's actually much more to mobility than just people moving out. There's also immobility, and we'll talk about it. So let's look at some, first, before we go any further, what the critics say, because there's always critics, right? It's social science, there's going to be critics. So Jochen Hinkel, he came up with the DIVA model. If you're familiar with that, it's a model that basically looks at coastal risk and coastal flooding. He did an excellent review article where he looked at indicators of vulnerability, and he critiqued the idea that we could actually measure or at least use indicators of vulnerability in certain ways. So he said, the various purposes for vulnerability indicators include things like identification of mitigation targets. So mitigation in this context, I think, meaning greenhouse gas reduction, not hazard mitigation. Identification of vulnerable people, communities, regions. Raising awareness of the issue of vulnerability. Allocation of adaptation funds. So in other words, instrumental use of the indicators to provide money to places that are more vulnerable. Monitoring of adaptation policy, and conducting scientific research. He said the vulnerability indicators are only appropriate for addressing the second type of problem, but only at local scales when systems can be narrowly defined and inductive arguments can be built. Whew. Well, he set a very high bar for vulnerability indicators and basically said it's all nonsense unless maybe you use indicators at a very local level and you're focusing on narrowly defined systems. I think that's a little bit too harsh. But it does beg the question, there's broader, and I do think that, frankly, that there's use of vulnerability indicators in more space than what he's described. But there is this idea that vulnerability indicators somehow can be used, as he says here, in allocation of adaptation funds. And so Richard Klein, who's used to be at least at the Stockholm Environment Institute, came along and said, well, basically, people want to know, ultimately, decision makers want to know which country is most vulnerable so that we can start shelling out funding so that they can do a better job. So think about the Global Loss and Damage Fund or the Global Climate Fund. We want to send money to where it's most needed, and the best way to measure that is through indicators. And I've been involved in some of those kinds of efforts. I was actually working on something called the Transboundary Water Assessment Project, which was under the GEF, the Global Environmental Facility. And we were developing indicators of transboundary river basins. And ultimately, what we were told is that someone high up in the GEF hierarchy wanted to have, or at least the board, the political representatives on the GEF Council wanted to know which transboundary basins were most vulnerable because they had a whole funding portfolio for transboundary river basins. Okay, so that was the idea. But what he says is that people working in this space are misguided if they think they can rely on external experts to develop a definitive, objective, and unchallengeable method to rank countries according to their vulnerability to climate change. There is no objectivist truth in vulnerability assessment. Any agreed approach will be a socially constructed outcome of a negotiation process. And this is, kind of harsh, also a little bit harsh language. Aren't we objective scientists? Don't we wear white lab coats and, go and inspect things carefully? But I've already tried to convey that these concepts are inherently difficult to measure. And they're also subjective decisions that you have to make, and we'll talk about that today. Subjective decisions at each point in the construction of an index that ultimately you're subjective. You're going to make certain decisions, based on your expertise. Having worked in the space of the Environmental Performance Index, so I've been working with Yale for 25 years on constructing global indices. These are country comparative indices. And often the critique we get, and I totally think it's justified, is you guys are a bunch of Westerners from high-income countries. What gives you the right to judge, and to actually develop these metrics? How can you say that they're purportedly objective metrics? And I think there's an element that's truth. There's, positionality is becoming an important concept in the social sciences. Just to say something parenthetically, positionality says where you sit and your viewpoint on life is fundamentally shaped by what your experiences have been and the privilege that you come from or the lack of privilege that you've had in your life. And so I just want to put that out there and acknowledge that that's a real issue. Finally, Berkman and Wisner, I think, take a slightly more pragmatic approach. So Johan Berkman was actually the author of one of the indices we'll be looking at. It's the World Risk Index. But they basically say, there's going to be a tension between complexity and mathematical parsimony. So the complexity is all the things that we've been talking about, livelihood and survival strategies, institutional and political power structures, etc., and the need for mathematical parsimony. The creative tension is between the need, in some cases, for a single number that expresses vulnerability and others for thick descriptions. This is Clifford Geertz was an anthropologist, and he had the idea of thick descriptions, meaning you go in and you sit with a community and you develop what's called an emic perspective on their community. That means you're looking at it from within, almost like the inside, rather than the edic view, which was from the outside. And so, we want to be able to get to that thick description in some cases, but there's also a need and there's also a demand. Frankly, I've seen the demand for indices. So I'll be talking about some of that demand as we go along here. So what are some of the country level indices out there? I already mentioned they can be used to prioritize funding. They can communicate risk. Some assess current risk. Some use climate projections to anticipate risk. Here's a disaster risk index. It's backward looking. It's a little bit dated now, but it's was out there, was developed by UNEP Grid in Geneva. And basically they looked at, deaths. It was an outcome measure, essentially, deaths from different disasters. And I'll just say also parenthetically that a lot of these analyses rely on MDAT, which is the MDAT is the Epidemiology of Disasters database. It's based out of Liège, Belgium. Have any of you used MDAT at all? Do you know about it? Okay, it's basically, it's the longest standing database on disaster outcomes, so displacement, deaths, other things. And they collect using media reports, they collect using official data from government agencies and from UN reports. But, the truth is it's very hard in the aftermath of a natural disaster. You notice the numbers are always round numbers, 15,000, 20,000, whatever. They're never like 19,998, So just to say that, the reason they're rounded is because they don't have a precise idea of how many people were affected. Anyway, so they use these data to develop this, and you can kind of see the patterns, India, Bangladesh, South Asia in general, with high disaster risk according to this index. Then you go to something called the GAIN. This was developed by Notre Dame, I guess we call it in America. And that's a university in Indiana. And they came up with this index that looks at, the various elements we've already discussed that go into vulnerability. And then they have a readiness component as well. Let's drill down and look at what's in the vulnerability indicators. So they have food, including projected food. So each of these, you'll notice, is broken down into exposure, sensitivity, and adaptive capacity. So all that background that you had on the first day is helpful now in understanding how they break down their index. So let's just take health. They say exposure, projected change in deaths from climate change-induced disasters. Probably a lot of questions about how they do that. It's not a trivial matter to project that. So they would want to have metadata and documentation showing how they do that or what the source is. Slum population is a sensitivity component, and medical staff is the kind of adaptive capacity. But each of these has those components associated with it. So they're doing a massive data compilation and ultimately data reduction effort. Then on the readiness index, we have things like, and these are using the same exposure, sensitivity, and adaptive capacity categories. So you have governance, political stability and nonviolence. Sensitivity is control of corruption, rule of law. And then lastly, regulatory quality, like the quality of the regulations in place, the policies. So this gives you an idea of what goes into this index. And these are some of the latest rankings. They update this periodically. I pulled this from the website this morning, so these are the latest rankings. The map that I showed earlier may or may not reflect the latest version of it. Fairly typically, high-income countries come out being very they have a capacity to adapt. India is here in the lower middle rankings, essentially, ranked 115. And Sri Lanka is just above it, and Iraq is just below it. I don't know how they come up with Libya being anywhere near 117. I think it's a failed state as far as I can tell, so that would suggest to me that it should be further down on the list. But you'd have to look at the individual indicators and the data sources they use to get better understanding of that. So this is turning to the project that I mentioned Johan Berkman has been involved in called the World Risk Index. You'll notice that the map doesn't, the map is very similar to the map that you saw with the gain index, but the framing is different. So here you see, it's more of the IPCC risk framing from the AR5 and the special report on extremes. Climate extremes. Exposure is on the outside here, and it's like an army tank connected in a production line with vulnerability. So like army tank treads or something, and or maybe gears in a machine. And you can then rank countries according to this measure of exposure in relation to the vulnerability, which they break down into susceptibility, likelihood of suffering harm, coping. I like the fact that they break out coping a little bit more. So I think there's elements where you can learn about what these concepts mean by looking at some of these things. Here you can see what they talk about in terms of coping capacities. And this is what's already in place versus I think adaptive capacity is more like what they can do, what a society is able to do and what it's able to plan for in the long term and in terms of and its kind of education systems and others. These are really investments that are made for the future, whereas this is really like what's in place now if disaster strikes, if you get that sense. And then they have a bunch of susceptibility indicators related to, public infrastructure, nutrition, poverty, dependencies, et cetera. And these are the hazards that they look at. And so you can see how they look at the exposure of the population divided by the total population. On the one hand, over here, you can see the weighting, so it's all very transparent. And then they basically add to that the susceptibility, the coping. And so this isn't what we call an additive. I think it's an additive model. I'd have to double check the math that they display in the report. One thing that you'll notice, though, is if you start looking at the correlation, again, this is an earlier version of the Global Adaptation Index, but I don't imagine it's changed tremendously. If you look at the correlation with GDP, it's pretty high, right? So you could almost say, at a 0.78, 0.8 correlation, if you look at GDP, you're basically looking at adaptive capacity. The value, though, could be that in looking at the deviations from the trend line, countries that are on the upper side of this are basically doing better for a given level of GDP than you might otherwise expect. And the ones on the below, like Angola, Qatar, Chad, are doing worse than you would expect for their GDP level. So that's a way of thinking about it. The scatter is a little greater when you look at the World Risk Index. And one of the things that's obvious is that some countries, because this has a very heavy emphasis on the exposure element, some countries like the Philippines, Guatemala, Bangladesh, Papua New Guinea, these are countries, Chile, that have very high levels of exposure, and that can be the case whether you have a high or low GDP. So that's one reason why I think this one has more scatter around the line. I see some puzzled looks. Everybody getting what we're doing here? All right. So issues with country level indices. Again, more critics, and I think they're also valuable. This is an article that basically took issue with an index called the Environmental Vulnerability Index that was developed by SOPAC, which is a group in the South Pacific, and they were looking at small island states. The lead authors from Australia, and they often tend to think that the South Pacific is kind of their research domain. So they basically said, we conclude that indices of vulnerability to environmental change cannot hope to be meaningful when applied to large-scale systems, and so we should focus on smaller scales of analysis. So that's interesting. They conclude somewhat similar to what Hinkle said, is you can't really do this at a country level. You need to do it at a much more granular level. So let's look at some granular level efforts. These are starting to get down below the national level, but not necessarily down to grid cells yet. So let's look at that. So what is the purpose? These are meant to show where the hotspots are again, describing the nature of the stressors in the most vulnerable areas to help design responses. People want to know where to anticipate, future disaster or hazards so that they can anticipate response needs. They, as I mentioned, they're used to prioritize and target funding. And then I would just say that there's a lot of academic interest in this area. And even though Hinkle said that, frankly, it's not a useful research endeavor, hey, we're academics. We're going to do it anyway. Sorry, that's just who we are. We want to develop new approaches. So let's look at SOVI and INFORM as two approaches. And again, when we do that exercise on Friday, we'll have a chance to get the data, get our hands into the data, and start looking at these things a little bit more and see what some of the issues are when you start putting data together. I may even give you a homework assignment beforehand if I'm able to prepare and enough. I'll get you some data ahead of time, and you can start playing with the data a little bit yourself. But this is what the SOVI includes, and I mentioned the SOVI earlier when I talked about the Mumbai and the New York City comparative effort. And so I conducted a SOVI in both cases, the difference being that I had different data sets available to me, so I couldn't necessarily measure the same things. And so you've got, Susan Cutter's SOVI over here, and you've got what became a federal government effort under the Center for Disease Control in the U.S. to measure SOVI. They actually just took it offline at the beginning of the Trump administration. They said, we don't want to know about social vulnerability. So that's an interesting political response. But what we did, the data is still available, in part because we have all the data available through a gridded version that we produced. One of the advantages of the gridded version is you can see that it eliminates areas that are not actually populated. So there's no SOVI where there's no people. And you can use that instead. But you can see the kind of variables that they're looking at in the construction of what they call the SVI rather than the SOVI. And so it's a useful metric, and we've used it a lot in research at our center. I've also mentioned yesterday that working with a woman named Beth Tellman, who was a former postdoc at Columbia University, is now at Arizona. We worked on a paper to look at whether outcome measures of the SOVI, like when you look at deaths and you look at damage to buildings and damage to infrastructure, does the SOVI actually help predict, which it should, in theory, help predict how many deaths occur in light of natural disasters? And so that's a paper. I could try to present some results of that later, just to show that it is an important element, is to do that validation against outcome measures. So this is an example of something I was involved in a few years ago where we went, again, under USAID funding. And the project was called WABIC, West Africa Biodiversity and Climate Change. And the WABIC project basically was interested in mangrove preservation in two countries, Cote d'Ivoire and Sierra Leone. So we conducted a very in-depth, well, I call it pretty in-depth, social vulnerability exercise, doing primary data collection in villages up and down the coast of Sierra Leone. Sierra Leone is between Guinea and Liberia, and it's sort of south of Senegal and all those countries to the north. And so what we did was looked at across. So first of all, let's just look at the characteristics of the sample, the communities that we were looking at. And the characteristics included things like fishing wild fish, processing fish. These are the livelihoods that people had. Small businesses, so you might have a little shop and you'd sell some water, canned, maybe some tins of sardines and batteries and things like that. So that might be a small business. Subsistence agriculture was also important. And these are just measured by the percentage of households involved versus the importance, meaning the amount of income that they got from different things. So you can see here that fishing wild fish was fundamentally the most important thing for these coastal communities living in mangroves. And so what we did is we used a bunch of indicators. This is exposure levels to different environmental stressors. And you can see in the north, high exposure, a lot of red, and then it starts to decline a bit. And that's partly because in this northern area, the mangroves had been largely stripped clear and rice agriculture had been put in place of the mangroves. So there was no longer that buffer to flooding, to storm surge, to major climate-related events. And there were also fire risks associated with some of the villages because when you're doing fish smoking, you're doing it with fire. If the wind kicks up heavily, that fire can get out of control, burn your fish shack where you're smoking your fish, and then it also will result in potentially burning your own home. So there were a number of things in the north that were more prevalent. Adaptive capacity, we also measured using a number of different metrics. These are all available in this report. And then finally, what's the next one? This is the total vulnerability score. The main point of this, not to get into too much detail, is to say that you can go down to the local level and collect data, and many of you, I think, want to do this kind of thing, right? You want to go in and do a participatory assessment, or some of you do. I see one person nodding. And so, you know, you can go and collect that data. So this would be a very good guide to kind of how to go about doing that, because we give a complete survey questionnaire. We give everything as by way of documentation of what we did. And we tried to follow the best practices. Overall vulnerability of households by quintiles. And so we found, for one thing, there's more vulnerability down in the red areas down here, partly because the communities are poorer also. So even though these communities, they have pretty high vulnerability, some of them, but the reality is that they're actually more prosperous in part because of the rice cultivation. And then if you look at this, which I thought was a useful way of summarizing some information about how much, this was a participatory research effort where we basically looked at how frequently people worried about different things and how important they deem those things to be. And so, you know, you can imagine a PRA exercise or focus group exercise where people are putting they're given a pot of like 10 beans or something, and they say, well, I'm really worried about this, but I'm less worried about that. And so they put 5 beans in the food category and 3 beans in the in education category or something, but then they don't have any beans left, so they don't put anything in the other categories. But basically, you can see most of these things are stuff that a lot of people in rural areas of the developing world would be concerned about and have high concern about: money, education, food, housing, shelter, health. These were all high incidence. In terms of importance, they had issues around not having access to markets, government aid. The transport infrastructure in this area is very poor. These are very isolated villages. And then you can see things specific to fishing communities like outboard engines and fishing materials. Where does environment come in? Kind of little dot right here, and also flooding. You say, how can that be? These communities are living at water's edge. The water is actually going into their houses at the rainy season. Flooding doesn't matter. Why do you think? Tell me. Yeah. They live in the water. They're always got water. It's been every year since they were children, they had water coming into their house. Do you think they're going to worry about it? No, it's part of life. All right. Now switching dramatically to the global scale, like going from village to local. I led an effort at Season, our center, to develop this index. We now have a version 1.10, which has been released. Well, if you want it, come to me and I'll get it to you. Okay, it's a global grid. It corrects some issues. The new version corrects some issues that I noted were affecting a kind of overestimate of well, we were saying that there's almost no deprivation in certain parts of urban areas of the developing world, and so we kind of corrected some parameters. This is a little bit the subjective aspect of index construction, right? I said there's no way that being in the center of Nairobi is equivalent to being in a rural area of like Tennessee or New York State. It's qualitatively different. I know there's wealth in Nairobi. That's not it. But I kind of realized that the numbers were not quite. They shouldn't. By exploring the data more fully, we found that they weren't useful. There were issues with the overestimate of kind of what I would call resilience in these urban areas. But what we did is we just basically did a mashup of a lot of subnational data that we had available to us, from subnational HDIs all the way down to satellite data at the bottom here. And then we also removed the slope in nighttime lights, which was meant to detect whether places were getting brighter or they were getting dimmer. If they're getting brighter, in theory, your deprivation levels are going down. But we found that they were so highly correlated with the overall luminosity, the actual nighttime lights, that they weren't really a useful addition. And in some parts of the world, like Europe, they were developing new lighting technologies and they were going down because of the new lighting technologies. So you have to look at those sorts of things when you do anything on a global scale. So we just removed the slope in nighttime lights in the new version. I don't have a map of it here. I can get it to you if you want, but it does correct some issues that we discovered. Anyway, it's a useful index, and one of the things I mentioned yesterday was that a colleague who does catastrophe modeling said that his catastrophe models do a better job of predicting damages when you include this data set. Well, the new version of the data set, not this version, but the 1.10 version, it actually does a better job of predicting damages. Finally, you can downscale and project future vulnerability. This was an effort led by a colleague, a PhD student who came to visit me from Italy. He's at the Euro-Mediterranean Center for Climate Change Research. And so he visited us this spring, and he wanted to project the Informed Climate Change Index to 2050 for Ethiopia. So we wanted to look at the Inform Index. If you're not familiar with the Inform Index, I don't have time to go into all the elements, but his particular interest was in this climate change index. I will just say that the Inform Index has some of the same rationales and background as the other ones, the World Risk Index. It's got more institutional backing. So the GAIN and the World Risk Index are kind of one group going ahead and producing something. This one actually is funded by UN OSHA and carried out by the UN, the JRC and ISPRA. And they do great work, and they also have a lot of other coalition members. So this is the Informed Climate Change Index, Risk Index, And again, you see hazard and exposure, vulnerability and adaptive capacity. So nobody's kind of reinventing the wheel completely in any of this work. But you've got all these different variables, and these are the variables that my colleague Domenico, I'll call him Domenico, his last name is Bovienzo, he was interested in. And he explicitly adopted the SSP framework that I mentioned earlier to project these variables into the future. So he used two as bookends, as it were, between the sustainability and the regional rivalry, which is kind of what many view as a worst case scenario in the future with both high challenges to mitigation and high challenges to adaptation. So the two variables that he was particularly interested in working on when he came to visit with me was projections of vulnerable uprooted people and vulnerability groups. So he used data that we had produced in the Africa Climate Mobility Initiative to find out what the future migration flows would be under these two scenarios into certain areas of Ethiopia. He looked at population projections, which we also have via the NASA CDAC I mentioned yesterday. He looked at food insecurity projections using crop models and existing data from the what they call the Living Standard Measurement Survey in Ethiopia. The World Bank conducts these LSMS surveys periodically, and basically he was interested in understanding how food security would change in the future based on various climate projections. And he also found data on Human Development Index projections. And then he came up with this overall climate risk index change. So this is the baseline with much higher vulnerability in eastern Ethiopia because it's largely dryland, pastoralist area, and a little less vulnerability, or whatever they're calling it. I think it is risk, sorry. So the risk is lower in the highlands in the west, but they basically had found that certain areas in particular, which is a low-lying, very flood-prone area on the border with Sudan, had very different changes in risk based on whether you take a sustainability approach and think about things being much more sustainable in the future, so great declines in risk, versus a high-risk scenario where there's greatly increased risk. And again, he also used I didn't mention this, but he used future projections of flood risk and drought risk and things like that from a physical science climate basis. So that's all factored into this effort. All right, so that's covering. Let's just take a look at the time. So I have 37 minutes remaining. So let's go through this part. I'm not going to take a lot of time to go through this because it's a little bit dated, but there have been a number of efforts subsequently that borrow these methods. So UNEP at a certain point had these global risk reports, and they essentially adopted a methodology very similar to what we did for this World Bank report. I say we because CSUN was one of the major contributors and data processors for this. And the idea behind the risk is solely to focus on that hazard component. Remember I said hazard, exposure, and vulnerability makes up the new framework. Well, at that time, there was an interest in just looking at the hazards. So the purpose, like I've mentioned many times now, is to prioritize more. One idea was if we do this global assessment, we can prioritize more localized vulnerability assessments to identify the highest risk areas within countries, and also a demonstration effect. And because we're scientists, we like to do cool things with data, right? So they had at the time a much different array of data that were available at the time that they did this. I say they because I wasn't directly involved, but colleagues were. And so at the time, there weren't a lot of data available on some of these parameters, and some of them were quite coarse. So let's take a look. The coarseness is, 1 minute, 1 degree for floods, which is extremely coarse. subsequent efforts have managed to do a much better job of modeling flood risk. So this is an example of some of the outputs just to give you an idea. So highest, this is single hazard, just cyclones. Gee whiz, cyclones occur in certain parts of the world. They're very localized, and they happen because of the production of cyclogenesis. And that's a whole science unto itself. It's differences in atmospheric temperature. You start getting a gyre going, and then suddenly that gyre goes all the way from the coast of Africa and hits the Carolinas or somewhere in the US. So the red areas have the highest risk decile. I wouldn't put too much credence in the drought work because it was a very coarse resolution, but you get a general sense. Remember I talked about Hadley cells in that first lecture on climate, third lecture on climate. Well, these red areas are all essentially adjacent to where the Hadley cells are important climate predictors. Flood risk, again, very coarse resolution, but you get a general idea that Asia, South Asia, or at least the Himalaya region and the Bangladesh, Ganges basin are all very high flood risk areas. Earthquakes, again, limited to areas where earthquake activity, the ring of fire around the Pacific and such like. And then volcanoes, very limited in terms of their spatial extent. And finally, landslides, again, restricted to mountainous areas. And then what you can do, what was kind of cool about this effort, is you can look at the highest risk deciles layered on top of each other. So the top 10th percentile of every risk, and just layer it on top of each other. And so these are, top 3 deciles exposed to drought only, but then you go down here and you see seismic and hydro, drought and seismic, drought and hydro, drought, hydro, and seismic combined. So you get these areas that are like multiple risk. And of course, India and the Gangetic Plain and the Himalaya region have pop out. And finally, you can just look, like I mentioned, take the highest of all of them. In the red areas are 3 to 5 hazards combined. Yeah, so you see these areas highlighted here. The Philippines, I'd say Nepal, Bangladesh to some extent, Myanmar, these are really high risk areas. They also combine the data on hazard risk with MDAT data. I just mentioned MDAT. So using MDAT, they could imply or deduce the level of mortality resulting from different different hazards. And so what you see is for cyclones, droughts, earthquakes, floods, landslides, and volcanoes, for Africa and East Asia and the Pacific, you can see different mortality rates per 100,000 in the year 2000. And low income Africa has, really off the charts risk for drought, for instance. But you also get for East Asia and the Pacific high mortality for cyclones. And then these are mortality. So these are not what we were seeing earlier, not the incidence, but the actual mortality results. But you see areas that have risk of mortality from different, at high level from different things. Now here's economic losses. What's the difference between this map and this map? Do you notice anything? So this is the mortality one. This is economic losses. Everything shifts up, right? Shifts to higher income countries because your economic losses invariably are going to be a function of how much you have exposed. And if you have a lot of assets, a hurricane hitting Miami is not the same as a hurricane hitting Maputo, in Mozambique. So that's going to see a lot more loss in Miami. And then what you can do is normalize losses by GDP, and then you get a better, more equal, let's say a more clear, just apples to apple comparison. And there you see a lot of economic losses in the Gulf region, Northern Gulf, Iran, etc. Okay. Finally, just to say that that was not the last word; it was just the first word on this work. Then there were, I think it was Provia, I can't remember, Prevention. The Prevention Consortium was under UNEP, and the Prevention Consortium developed higher, more high-resolution versions of the data that I just described and went on to refine the work in various ways. And this is just the most recent effort. It was published, I'm sorry, I didn't write the publication date down here, but I think it was in the last 2 or 3 years. This is an example of one of the data sets that we use for that CASA assessment of urban vulnerability. So remember, I went through during the urbanization session results for that USAID funded assessment of different parts of the world. And you can see that people are continuing to develop hazard mapping. So this is really the meat of what I want to talk about today. And I have 30 minutes. So I'm going to use an example of work we did in Mali. And the Mali work was funded by USAID under a project called the Africa Resilience to Climate Change Project, and or ARC, ARCC. So just as a sort of, again, why do we do this? Mapping can illuminate key vulnerabilities in the coupled human environment system and in turn inform where adaptation may be required. Mapping will not necessarily tell you what needs to be done now to build resilience. So I think you just have to be careful about understanding the value of mapping, what you can do with it. But to do the actual, like, what should we do? You need to go to the ground and you need to talk to people. There's no escaping that. So this was, fundamentally a desk exercise, where we had data from a variety of different sources that, again, followed, in this case, the earlier IPCC framework, vulnerability framework, where the overall vulnerability was a function of exposure, sensitivity, and adaptive capacity. And we had a variety. Well, we worked with climate scientists, so I just want to say up front, if you want to undertake this kind of thing in your own, here in India, I would say you'd be very wise to work with subject matter experts in different domains, and particularly in the climate domain, you want to work with people who know how to work with climate data and not simply come up with stuff on your own, thinking that you can kind of figure it out on your own. So for instance, one area that was considered to be important that I wouldn't have included by a colleague who has worked extensively in West Africa. She was the one who led the vulnerability assessment in Sierra Leone, by the way. Her name is Sylvia. And Sylvia Traska is her last name. Sylvia Traska, somewhere maybe, yeah, Sylvia Traska listed here. She's kind of an unusual person. She's sort of a geographer. She's really a hardcore climate scientist, but she also studied geography in France. And I was stunned by her ability to carry out a vulnerability assessment in Sierra Leone, given that her core competency is climate science. Like, that's what she's really known for. So that's just an aside. So some people surprise you sometimes, right? So anyway, the percent of precipitation variance explained by decadal component in West Africa is very important because there's something called the decadal oscillation in climate. And so that decadal oscillation actually, the Great Sahelian droughts occurred about a decade apart, right? 1970s, mid-1970s and mid-1980s. I was there for the second round in 1983, well, right around 1984. In those Sahelian droughts, excuse me, were a function in part of this decadal oscillation in precipitation. But there was just some basic ones that you might think about yourself: average annual precipitation, the interannual coefficient and variation in precipitation. So how much is your rainfall varying year on year? All these data were, in the most part, the climate data were all gridded. We had long-term changes in temperature, and flood frequency was another factor. Then we had these sensitivity and adaptive capacity. So remember, I mentioned long-term kind of capabilities to respond, things like education of mothers, market accessibility, so road infrastructure related to markets and things, health infrastructure. We use something called anthropogenic biomes, and I'll talk about it in a moment, but you'll see a map of it in a moment. But basically, one of the things I was concerned about, knowing a little bit about Mali, was there's a whole area in the middle of Mali that you would predict to be very dry and very arid and not productive. But it's actually called the inland delta of Mali. So the Niger Delta, the Niger River flows, and during the flooding period in the middle of the monsoon, it actually goes out and braids, and it goes braided for quite some distance and creates a huge floodplain in the middle of Mali. So this is something we wanted to capture, and I'll show you that in the anthropogenic biomes data, irrigated areas. And then we had these sort of sensitivity measures, which are mostly outcome measures like poverty, child stunting, household wealth, et cetera. We also had something on malaria. So let's take a look at this. There was some interest, and I published an article. I think it may be among the articles that was listed on the last day of the course this week. It's an article that looks at physical variables from remote sensing data and their application in this vulnerability mapping work. And so this is an example of if you looked at this here, coefficient of variation in precipitation, you'd get 5 like half-degree grid cells, right? You wouldn't be able to distinguish that much between different areas. So what I wanted to do is get something higher resolution. And one way of looking at, whoops, this thing stopped. I just need to have Rahul touch it, and then it'll be good. And feel free to advance it to the next slide while you're working on that if it's. So you think it's working now? Okay, great. Thank you. You touched it. So the interannual variation in greenness, which is some of you know is the NDVI, those of you remote sensing experts out there, was one way of doing that where you could see how variations in greenness are lower in the south where there's higher rainfall. Then they get very high in the Sahel, upper Sahel, and even into the Sahara region. Then they're low up here. Why are they so low up in the north? Can someone tell me? Does anyone know what's up here? Is it raining again? No, it's the Sahara Desert. So there's no variability in greenness because there's no greenness to start with. Just a trick question, sorry. So one of the reasons why we cut off Mali at about this latitude was we didn't want to include parts of the extreme desert regions that if you had those in there in your index construction, you'd get extreme values for just about every variable. And we just wanted to avoid that. So we cut off Mali. I think it's, I don't remember what latitude, maybe 17 degrees north. And then we had flood risk, which was a higher resolution version of the flood risk data I described earlier based on some more recent analysis that was done. And so you see the inland delta showing up here where the floods occur frequently. And then we had other data from remote sensing, including soil carbon. So much higher soil carbon in the north, in the southern parts of the country. And then for each variable, and this is very important in index construction, you just need to be transparent how you do this. But you have high to low precipitation. So this was really low in the north and very high, relatively speaking, in the south. So you have to create some transfer function, essentially, where you take the native values in millimeters and transfer them to a unitless scale, 0 to 100. And in our case, 0 represented the lowest vulnerability, and red, or 100, was the highest. So in this case, we had to invert the scale, right? Precip's high, that's good. That's bad for, precip high is good for vulnerability, and precip low is bad for vulnerability, and so we just inverted the scale. I'm going to confuse myself here. Transformations to a common unitless scale. That's what I was trying to get across. Other transformations that you see are what I mentioned earlier, the greenness, variation in greenness. So you see the high variability in that Sahel zone. And then I mentioned 17 degrees. I was close. It was 17.2 degrees north latitude. And one of the things that we tried to do very carefully in our final report was look at the variation, so provide histograms of the variation of the raw data, and then show that in some cases we did what's called winsorizing or trimming the tails. So you have this very long tail where there's this coefficient of variation that's like way up at like 0.8, 0.7, and we wanted to trim that. So we simply said anything higher than 0.5, if it has a higher value than that, we bring it back down to like 0.5. Does that make sense? And then we rescaled everything on the 0 to 100 scale. Not quite normal distribution. And this is where you might get into things like if you had a skewed distribution, you might want to log it or something of that sort. I don't think in this work we actually logged too many of the variables, if any. But all of that is in the metadata, and I'll get to the metadata in a moment. These are climatic data, gives you an idea of the precipitation, long-term trend, and temperature. So temperatures are getting much hotter up here. Does anyone know why that is? Some of you physical scientists? Closer to the desert. Drier areas, the ground heats more, there's less evapotranspiration, right? So all those things lead to hotter, like it's going to get hot. If the temperatures overall are getting hotter, it's going to get hotter in drylands than it will in more moist areas. This is the flood, remote sensing of NDVI I mentioned earlier. Flood extent, again, transformed. So you have very high flood risk in some of these areas along the Niger River. Anthropogenic biomes I mentioned earlier. One reason I wanted to include it is because it includes rice growing regions in the Niger Delta. Those would be lower vulnerability because we just coded them in a certain way. Yeah, you have a question? Yeah, it's gridded. Yeah. This was from Chirts, CHIRTS. Some of you are familiar with. We interpolated. Yeah, I'm going to show you how we did some of that in a bit. Like some of it wasn't gridded, right? Some of it was, um, uh, some of it was based on admin 2 or admin 3 level data. Some of it was based on point data. So I'm going to talk a little bit about that in a minute. Just to give you quick headline results, this is the exposure, very close, very clear south to north gradient based on rain, mainly on precipitation, but also variability in precipitation and flooding and things. Sensitivity, you can see, is a kind of goes out from Bamako, the capital, a little bit, but you have high sensitivity, especially because of high infant mortality in the southeastern. This area happens to be, and we'll talk about that, but it happens to be one of the areas that's now affected by the insurrection in Mali, and where there's high levels of mortality related to armed groups and vigilante groups. And then adaptive, and this is now, it wasn't the case at the time that we did this work. Adaptive capacity, you can see, is more widely, there's sort of moderate levels of adaptive capacity. By the way, this scaling here, and the scaling is important. Now, maps communicate, and you need to choose your scale ultimately. We just took the 0 to 100 and we mapped it directly. But you could equally well do quintiles, and I'll show you a quintile version of this map later. The quintile version basically says, for all the grid cells, we're going to take an equal number in the bottom fifth, the middle, up to the top fifth, and we're going to take the number of grid cells that are in each one. Just to show you that you can also look at these variables in terms of like these maps in terms of the population covered by the highest risk areas, even though it looks like a large area, is only basically affecting 5% or 6% of the population, whereas medium high is around 30% and it goes down. The most risk is right in these orange areas, both densely settled and also quite, I say risk. See, I just changed it. It's vulnerability. So it's easy to slip up. It's really about vulnerability. So vulnerability is a construct. I already mentioned that it can't be necessarily directly observable. I can't go up to any individual in this room and say you're high or low vulnerability. It can also be considered a pejorative by some communities, so you have to be careful how you use it. People don't want to be necessarily labeled as vulnerable. You know, they might want to be labeled as resilient or, you know, capable. Vulnerable doesn't necessarily have good connotations everywhere. Index construction, I mentioned, you know, there's just a bunch of things that go into index construction that mean you have to have pay a lot of attention to details. 15 minutes. And then data available in many developing countries may be out of date, of low spatial resolution, of low validity and reliability. So this was an issue we faced in Mali. We were able to get our hands on some pretty seemingly high quality data, but I looked at some of them and I said, you know, this doesn't pass the sniff test, right? I'm looking at these data, they don't quite jibe with what I might know about Mali. There was a poverty map that seemed to be kind of like showing speckles of high and low poverty next to each other. And things like that, you need to be kind of just use your intuition and maybe a little bit of your knowledge and common sense to sort out. But that results in uncertainty. Data transformations. So that was your question back there. Yeah.
In the development of the index, you know, the variables having very high correlation.
Yeah. Yeah.
So why we should take the variables which are having very high correlation among themselves?
Let me get to that. You're always anticipating. You have great questions. So we'll talk about that in a second. So this is just to say that we had data that were, for instance, from the demographic and health surveys that were point estimates because they take cluster level. They don't want to reveal the populations in each location where they sampled. So they take, let's say, 100 households, and then they don't randomly, but they assign a cluster point, but they may even offset the cluster point a little bit because they don't want to identify the households that are associated. It's very sensitive information. Things like AIDS and things like that were asked about this, the people who. So basically, some of these were point level data, and so we had to do kriging. Spatial kriging means you basically create a linear interpolation between the space. So many of you are familiar with these concepts. Some of them were already in raster format, but might have needed to be converted to a common raster grid. So what we do is a raster to point first. So you get the centroids of every, I think we did that. And then we took the points and we regridded using a common regrid of 1 kilometer basis. So everything was essentially everything was harmonized according to a common grid. Then you had some things that are polygon data, and then you would just basically do an equal allocation of the value for that polygon. And so that shows some of the uncertainties that come because you may have data at the commune level, but you may have data available at the point level for DHS clusters, and you're interpolating between them. So that's great if you have commune level data, but if like infant mortality, all you have is region level data, which is their kind of equivalent to states. So these are issues that we faced, and I won't say that we could completely overcome them, but you have to be transparent about some of the issues. FuseNet had data from, these are the CHIRTS data, and it was a very high resolution for climate data. But you would have to realize that underlying that is the meteorological station network, which was very sparse. So they're using a combination of met stations and satellite data to come up with these measures. And then I already mentioned the anthropogenic biomes, which are at 1 kilometer. But again, part of the reason I wanted to include anthropogenic biomes is they very clearly delineate these areas of rice growing in the north that have higher potential incomes. Then we also used projections of climate to look at future climate vulnerability. And one of the things we did is in some of the RCP 8.5 scenarios down here, what you see is we actually go up above 100 because we didn't want to use the original scale, but we wanted to show that there's additional vulnerability as a result of the climate exposure. So that tends to be a relatively small part of the country up here. But you get the idea. We were trying to convey that there's actually additional vulnerability. Generally speaking, what you would see is if you compared the original version to the 2050 version, is vulnerability shifts northward. So generally speaking, you see a higher vulnerability in the north. So one of the things I mentioned was about the Met station data. And so we wanted to look at the standard error for temperature and rainfall based on the Met station network that we had available. Lower errors in white, higher errors in darker colors. And what you see is Bamako and some of the cities like Mopti and over here is Kai. They had good Met station measurement, but the rest was just interpolated or using satellite data. So we convey uncertainty in the data here by looking at the Met station. Here we take a look at areas that had higher or lower sampling for the demographic and health surveys. So the white areas, again, have higher resolution data. So what you could say is generally we have much more confidence in Bamako and the areas in the southeast of the country than we do in other parts of the country for these measurements. We also looked at PCA. So this gets to your question. So if you use a PCA approach, principal components analysis, you're taking into account the fact that there's high multicollinearity among some of the variables. And then we simply looked at using newly identified PCA. I'm not sure if I have a slide describing the individual components. I'm not sure I included it. But what you see here is the map of the PCA base and a map using quintiles rather than strictly following the 0 to 20, 20 to 40, 40 to 60 categories. So the quintile map actually does, what we wanted to do is essentially say, if you were to use PCA, would you get dramatically different results? And we found that generally speaking, the results were somewhat comparable, but the additive version has a higher vulnerability in this zone right here than the PCA version. So I do have a map, but I don't have the individual variables that went into each of these principal components. But the maps basically show your climate principal component, your household vulnerability principal component, your child stunting, Africa, the transportation, access to markets, et cetera. So each of these represents a different component. Because the PCs are uncorrelated, the scores associated with each PC encapsulate a unique aspect of the overall socioecological vulnerability represented by the original data set. So those of you who are more familiar with PCA, you understand that process, but we can talk about it more when we construct an index for India. We also did sensitivity analysis. So we looked at what happens if you change the weighting of the variables. So weighting, if we did equal weighting rather than increase the weight of some variables like the demographic and health survey data, which we did increase the weight on, you see that red areas indicate higher vulnerability in the unweighted index. Yellow to blue indicate lower vulnerability in the unweighted index. So when you do the unweighted index, things look a little better over here and a little worse over here. And then we provided documentation. So what does this mean? We show how we transformed each variable, and then for each of the indicators that we use and the variables that went into those indicators, we basically had a full citation of the data set, computational approach to processing it, what were the statistics for the raw data, what were the ways that we transform the data, the spatial resolution of each data set, and then we had a rationale somewhere in here for why we included it up here. And the rationale was supposed to map to vulnerability. So in this one, it's household wealth index. High levels of household wealth are assumed to contribute to greater resilience, while low levels of household wealth are assumed to lead to greater sensitivity to climate shocks, with greater likelihood that households will need to sell assets or migrate during periods of prolonged drought. So that was our rationale for including household And then we had limitations on each of the data sets as well, what some of the limitations were. We did do, after this, we had worked with colleagues at USAID, and we trained them in the methodology for doing this climate vulnerability mapping. That's why if you see in the readings, there's a step-by-step guide to vulnerability mapping, that was developed in part for our colleague at USAID, and then we refined it with a visiting scholar who came and visited with us, Ibrahim Idris, who is from Djibouti. And anyway, the point is that we did some further analysis. We did some further mapping in West Africa, including in Niger and Burkina Faso. I say we loosely because it was really this guy, Jeremy Chevrier. Jeremy worked with USAID, and he got trained in our methods. And what we wanted to do was see how these maps were actually being used in policy contexts. And we basically used a framework that's widely used now that basically says that the uptake of information and policy processes is determined by three major criteria: credibility, salience, and legitimacy. So credibility meaning, do people believe that your work is actually, strong? Is it good or not? Do they believe in it? Salience means at the time you present the work, is it actually something that policymakers care about? Do they actually care about it, or is it one of those things like under the current Trump administration, vulnerability, schmulnerability, we don't need this anymore, where we don't care about that. And so salience is important for uptake, because if it's not salient, the decision maker won't act on it. And legitimacy, credibility really has to do with your scientific method. Legitimacy is kind of like, oh, Columbia developed this. Oh, Yale developed this. Or, oh, Jamia Millia Islamia University developed it. And they have a good reputation. And so, but they also can be in terms of whether it's viewed as participatory or not. Was there actually an adequate amount of consultation in the process of developing the index or not? We did have some opportunities to interact with people in Mali on and off, and they gave us some feedback early on in some of the things that we were doing with the mapping, so that was it. Embeddedness is the last characteristic, and that means is the mapping actually, or the index, is it actually embedded in a government process? So in some countries, what you'll notice is indices actually become barometers of whether you're doing your job or not, whether the ministry is performing its responsibilities or not. And so if an index is actually formally embedded within a government process, you can bet that the technicians and the civil servants are going to pay attention to that particular index and going to want to meet that challenge. Maps are important boundary objects. This is a concept that basically, the way I describe it is, if you're a public health expert, or you're coming from water resources, or you're fisheries or whatever, you each come at the issue of vulnerability from a very different perspective. And so in the case of Mali, what we found was the maps served in a way that others had documented they served, is that it becomes a conversation point, a starting point for talking about whether you believe or have distrust, maybe even in some of the results that you see in the map. So, but it's a boundary object in the sense that it enhances conversation across different sectoral interests. With power comes responsibility. We learned that from who? It was Spider-Man, right? So with power comes responsibility. And so we need to emphasize and be transparent in the methods that we use and discuss limitations. There are a bunch of questions that we wanted to ask, and we hope to get funding to get into further, like what's map literacy like among decision makers? Do they actually, like, my wife can't read a map. It's no shade on her. She has many other strengths. But maps, forget it. Like I tell her in the car, look ahead on the road to see if we can get to a rest stop or go to a gas station. I don't know, where are we going and what are we doing? So that's just like her capability. Like that's not her area of strength. In the same way, we might imagine the decision makers don't necessarily have the ability. They weren't trained necessarily in thinking about spatial data and spatial knowledge. So you can go down this list, but there are a lot of things like, do the results conform with their preconceived notions about the way the world is? And if the maps don't conform, then immediately they'll say, where'd you get that data for such and such? Oh, that came from some international source. We only trust our local hydrology department, that kind of thing. So these are things that we've encountered over the years. All right. All of you should have read, it was in the assigned reading, and maybe, I'm going to run out of time to go through this in very much detail. I just want to be respectful of everyone's time. Oh, I'm down to 29 seconds. Not good. All right. So this was our meta-analysis of vulnerability mapping. I want to skip through the kind of like what the composition of the sample was, because that's interesting, but you can read about that in the journal article. But one thing just to point out, that most of the indices that we looked at for vulnerability mapping, again, this is it's like the Mali mapping we did, but we took a sample of like 75 to 80 different cases around the world and looked at the methods that they use. So that's the idea, was we took a large sample. It's 84, sorry. So we had a group of people, so we didn't just do it. I didn't do it on my own, but we did coding, and then we coded according to what we thought was best, and then we compared our coding, and where there are discrepancies, we had got together and we talked through those and came up with a common understanding. So most of the maps use index construction with components. A number of them use index constructions, but without necessarily separating it into separate components. And then components constructed, but no index, so they didn't actually aggregate it up. And then some use things like PCA. And let's just look. These are some of the climate-related indicators that were viewed, mapped. So these are the things that they were worried about vulnerability to: temperature, precipitation, flood, drought, etc. Some of the other indicators they looked at were things like land use and land cover, vegetation distance. And so a lot of different climate parameters. That's not so important. 50% of studies relied on linear aggregation of the index construction. 62% use weighting of some sort. Again, these are all subjective decisions that come along. There are other approaches like cluster analysis, GEONS. And then at each stage of index construction, it's just important that, this is where the subjective part comes in. Choice of indicators, analysis scale, measurement errors, transformation, normalization, factor retention, weighting. These all influence your results. Uncertainty analysis is important. We found that uncertainty analysis was only conducted by 40% of our studies. 20%, however, it was only textual. So it's basically saying, we know there's uncertainties here. We know that we don't have a perfect grasp of all these things, but that was all they talked about. 18% actually provided quantitative assessment of the uncertainty, and 2% represented maps to support quantification. Anyway, we also talk about mapping and how there's actually best practices in mapping, and some people aren't really aware of that. Obviously, a lot of the journal articles that we looked at, they were written by scientists, mostly for scientists, even though they usually had a sentence at the very end saying, this is vital for policy. But they don't really specify, and they don't really show that they actually made an effort to talk to policymakers. So, but if you're going to start talking to policymakers, start looking at best practices for map construction, because it's really critical. You can at least eliminate some of the lack of geographic literacy or reduce it by starting to look at better approaches to mapping. I'll skip some of this in the bottom. I think validation is so I talked about SSPs yesterday. Only recently have people begun to use SSPs for projecting future socioeconomic scenarios in vulnerability mapping. The big challenge here is that you have multiple scenarios. So you can't map just one outcome like this is the way things are going to look like in the future. We could do that with the Mali mapping, because we held all the social vulnerability elements static and just said, if you take today's picture and you overlay on it a future climate, this is what it would look like. But we know that the social systems are evolving too. So you would want to look at future socioeconomic pathways. Validation is important, emergent phenomena that makes it difficult to measure. So, I mentioned already several times that you can't directly measure vulnerability. So what can you do? One is you can look at the outcome measure, like I said, we did in that study of the SOVI and looked at flood and disaster outcomes, flood outcomes. So we looked at floods, and we looked at outcomes in terms of loss and damage, both deaths and damages to housing. And that was a form of external validation. And we found that the SOVI was reasonably predictive, at least in the United States, of damages, or actually of deaths. Damages a little bit less so. Internal validation is when you do things like sensitivity analysis, or you look at alternative ways of constructing your metric, your index, and you say, based on these decisions I made, this gives a certain level of, like we did with the PCA. PCA looked kind of like the original vulnerability map. So we kind of said, you know what, these two are pretty similar. And so therefore, there's a certain amount of internal validity or coherence to the approach that we address. And finally, these are just some recommendations for vulnerability mapping. Maybe when we talk about index construction, I'll come back to these for another lecture. So for now, what I'll do is just pass the mic around and we can do a little Q&A. I know you're all hungry too, so. But we started, I think, 5 or 10 minutes late, so maybe we'll just give a few questions.
Thank you, Professor. If I want to study multiple indexes on the same geographical area simultaneously, so what would be the interplay between those indexes, and what should be the better approach? Do we have to overlay all the indexes, or do we have to reassign the weights to develop a new one? Thank you.
So when you're saying multiple indices, do you mean developed by different groups, like maybe comparing for the same state of India, an index developed by one group versus 2 or 3 other groups? I think there could be multiple methods. You could look at RMSE, the root mean square error, is one metric of divergence. You could look at spatially just, how they line up against each other with some visual interpretation. I'm sure there's, among our geospatial experts here, there's even more methods that could be used. My guess is that for any given index, it's going to have a different purpose in mind. So depending on the purpose, the results will vary, And remember, back when we were talking about vulnerability metrics, was it yesterday? Day one. Anyway, when we talked about that, we said for any index or any vulnerability measurement or assessment, you're looking at the vulnerability of a group or people or system, or maybe an economic livelihood like fisheries, to a stressor at a particular place and time. And so because of that, you're unlikely to probably find 3 or 4 independent indices that purport to measure exactly the same thing. Does that make sense? Yeah.
Thank you so much for this lecture, sir. So my question revolves around the data credibility these days, which you talked about. So when we are presenting our research, like Indian research abroad in conferences, when we mention the source of the data, there is always some second guesses, because obviously the audience there is not well versed with the situation and circumstances in Indian context. So, and sir, there's a key problem here, that the climate perception amongst the audience, which I worked in my thesis also as a add-on, it is I won't say different, but it is not at par with the reality of the climate changes. For example, if we talk about the rainfall variability or something, so there's a perception amongst people, but when it comes to scientific findings, according to the data, it comes out to be sometimes a very astonishing finding at a very grassroots level. So, sir, when we are presenting the research, people have some doubts about the data credibility, that maybe these results are somewhere probably not well presented or cooked or somewhere like that. So, sir, how do we, counter that, or how do we tackle that kind of a situation? Because the perception of climate change is still in the audience not at par with the reality of presenting it according to a sample size, like a city, Indian city, to a foreign audience. Thank you, sir.
So you're talking about presenting results of Indian research to foreign audiences? Yeah, well, my, yeah, well, so I think all you can, so, I'm a data person fundamentally. Like a lot of my work has been around data preservation, data management, data documentation, and that sort of thing. And why I emphasize the need for metadata in the Mali case is ultimately you need to know where the data came from, their provenance, the methods that were used to develop the data. As a scientist, that's your responsibility. Now, how you communicate that to the end user or the audience is basically you can't just wave your hands and say, these data, to some degree in a verbal presentation, you can only present so much, but you should have the backup material in your report, and that should be available for anyone who wants to, investigate or dig deeper. And I have had, my fair share of cases where someone basically says that's nonsense. But usually it's even if it's a decision maker, it's someone who has training as an engineer or a scientist, and they basically, they call you to account. So you have to be ready and be prepared for sure. Yeah. Are there any one or two more? Okay.
Sir, actually, I have a little concern about the vulnerability mapping. So, can I go with a Mali mapping of the vulnerability mapping of Mali? Yes, sir. Yes, sir. This would be okay. So, sir, my concern is that if we map the vulnerability mapping, so it shows that normally, if we see that in the places close to the equator or in the northern part, so like it shows that the northern places are a little more vulnerable. But if we look into the population distribution in the northern parts, the concentration of population is like comparatively less. So during the policy making or during the basic perception, so it clears that those areas in the northern part, those areas more vulnerable, but the number of population or the population distribution of those areas are less comparatively. So during the policy making, I think we need to consider that if the southern part, the area is less vulnerable, in the less vulnerable zone, but the number of population affected by the climatic disaster or the climatic vulnerability, the number of people are numerous. So we should we like more to concern about rather the vulnerability zone. So we, I think we also need to consider the population distribution of or the number of population affected by those vulnerabilities.
No, that's perfect, and that actually illustrates. This slide illustrates the point. What happened was actually USAID, funded a follow-on effort in Mali called the Climate Adaptations. I don't know. There was some sort of climate adaptation activity in Mali, and they actually did choose this area because it's both the most populated, the orange area I'm referring to, so just around Mopti, and they focused on that area. I think in part because it was a moderate vulnerability. It wasn't at the highest level of vulnerability, meaning that it wasn't in a place where maybe your interventions would not have much impact, but it also was an area that had a relatively robust population that could be helped. We have a hand here, and then my friend in the back.
Thank you, Alex. Can you go back to that table of indicators in which you have the time frame? Yep. So my question is regarding the temporal range. So it's a good idea to have, I think, long-term ranges for annual rainfall, temperature, and all these data sets. My question is that will it be a good idea if we take similar ranges for all the data sets? And one more thing, in addition to this one, we are talking about the climate change. Will it be a good idea if we take long-term averages post 2000 era because pre-2000 era things have changed drastically in reference to the temperature, precipitation, the patterns have changed over time, and we are considering the long-term average way back from 1950s to 2009. So my query are two queries. One is that will it be a good idea to use the same time frame for all the data sets? And as we are talking about the climate change, so will it be a good idea to take the latest data sets? Because I think it will generate a good output.
So just to recall, this was conducted around 2014, 2013 actually was when the work was done. So the data may appear very old. In many cases, they are old, but they were the best available at the time we did the analysis. You can't really, unfortunately, for most of the social vulnerability variables, we didn't have time series. So it would have been lovely to have time series for a lot of the social indicators, but we didn't have those. We could have, and this is actually a good and valid point, the demographic and health survey has been conducted in multiple waves. So we might have been able to construct some change in certain variables, but that would you need to presuppose that we actually had the same exact measurement. So for household wealth, could we get the same indicators in the earlier waves as we have in the later waves? So you're bringing up some really important points. As far as the time frame, yeah, you could say going back to 1950 for trends may not be that valuable. We were trying to give a sense of like the longer term trajectory. And at that time, if we had started in 2000, we would have had data only up to say, what was the latest date? 2009. So we would have only had 9 years. Yeah, you would hopefully go for data post 2000, maybe. Yes.
Alex, my question is, or inquiry is regarding the uh, indexes which has been developed is mostly classical in nature because weighted and PCA based. Now, in the scenario of machine learning based algorithm come into the picture, where are these indexes is going to look like? Where, how do you see application of machine learning in index development?
That's a great question, and I'm going to leave that to your generation to develop in part because I haven't been using machine learning tremendously, or AI, for instance, is possible. Like Geo AI is now rising in terms of its importance, and people are looking at. I guess what I would say is, as long as it's relatively transparent and not a complete black box, then machine learning it can be a really valuable thing. Uh, and there are certainly advances. I'm going to actually take it upon myself to look up to see if there's literature on this kind of index construction using machine learning and see what the literature shows today. Because I have to be honest, I haven't looked at it, looked at that particular question. Thank you. Yes, and one last question, I think we'll break for lunch. Raman's not here to tell us we have to get out of here, motioning us to leave, but I'm going to take it upon myself to.
Thank you, Professor. I just really wanted to know what are the criteria for the selection of indicator for assessment of urban vulnerability, considering that each cities has different meteorological topography and all these different conditions. So considering that, I really wanted how to define these indicator in that terms. Sorry.
Well, that's the beauty of index construction. You get to choose, right? So you have data for your city. You can choose what you think are important variables, and provided you can get data for them, you can actually start measuring things that might not be feasible at, one of the things that I didn't show work we did when we moved from Mali to the regional scale. We did something on the entire coast of West Africa. And that was interesting exercise, but what we couldn't do is get comparable data across all countries. So we were reduced to a reduced set of data because you wanted to have the same metrics apply everywhere. And in the case of a single city, think going down to a local scale, you might be able to get data from your local planning office that we would never dream of at a national or regional scale. Does that make sense? Am I answering your question?
So, Professor, I really wanted, for example, in the plain areas, comparing the plain areas and the mountainous areas. In that perspective, what are the selection criterias in that manner?
Okay, I'm going to say the same thing. Essentially, it's vulnerability of what? In this case, is it to heat, or is it to flood, or is it to drought? To what? So it's a vulnerability of what? The city. Sorry, to what? The flood, drought, heat in a particular time or place. And so you will want to choose your indicators based on the risk factors that you think are most important. If it's a floodplain, then it's going to be flooding more likely. It could be also extreme heat. If you're way up in the Himalayas somewhere, it's going to be landslide risk. It's going to be rainfall, flooding, and maybe some other metric that I'm not thinking of, glacial lake outflows. Does that make sense? We can talk more. Anyway, I don't want to keep you from lunch, so let's go ahead and break. Is that right? Are we doing that? Is that what we're doing? Okay.